My first talk is on the Bobcat development prototype. When HP was designing the HP-92, HP-91s were used to build the HP-92 prototype development system. At the time, even though plastic injection molding was done on site in Corvallis, it was still the longest lead time item. Developing the plastic tooling for the injection molding was a long lead time item. So the 91s were used to develop the 92. This is one of those HP-92 development systems, and the purpose of this talk is to walk you through that development system. So first, we'll zoom in on the label that's on the unit. What it says is that it is, the first label that was on there it says it's a Bobcat, and if you look up Bobcat, that's the 92. This was unit number 5, so there are at least 4 more of these out there somewhere in the world, or at least there was. And then later in time, somebody added the 92 to tie up the loose connections between the products. Okay, I'm going to go through this talk quickly because I'm going to try to insert an extra talk in on the Pioneer family. So when I skip through there quickly, you notice on the development system there's a toggle switch up in the corner. Well, it turns out that the 91 had 3 switches and the 92 had 4 switches. But the 92 had 2 new switch functions. So one of those switch functions is the toggle switch. And so where did they get the other one? Well, turns out that the 91 had trig functions and had a degrees, radians, grad switch. The 92 did not have trig functions, so they repurposed its switch to do the begin, note, end bond function. So that's how they get the 4 switches. Now, this is the development system keyboard and display. So it's got the standard LED display. Zooming in on the keyboard. And now comparing the prototype keyboard to a 92 keyboard, you'll see that there's a one-to-one mapping with all of the functions on the 92. So this is the later version of the 92 development system. So looking at the bottom, there's a socketed IC that it didn't fit clearance-wise inside the case. It's normally soldered directly to the board, so we had to cut a hole in the case for it. And where there's normally just a power connection, there's this cable connection out. We'll see that cable connection is not only power, but it's also data. Okay. Someone was talking to me about documentation. So this is what's euphemistically called a dumpster dive. This is me collecting things that were about to be thrown away. There is no documentation for this system, so we don't have the pinout for this, although we may be able to derive it eventually. Okay. Now, for your reference, this is the inside of an HP-91 and an HP-92, and they look quite similar. For any of you that repair them, I'm told that it's a standard practice to put repair notes inside these units. And so if you open up your unit, you may find the repair history for your unit. This is the inside of the prototype unit. Looks a little different. So first, a special thanks to Tony Nixon. He knows about how these things work, and he said that this was a PIC chip, this is an ACT chip, a ROM 0, 4 RAM chips. And these 2 parts, we weren't sure, but one of them has an 1820 number. For those of you that work with taking HP systems apart, HP was a big enough consumer of electronics that they forced suppliers to put HP part numbers on them. And 1820 is the standard prefix for integrated circuits. And it so happens that there's a reference that decodes what those 1820s are in the HP briefs. So this is the 1820 reference numbers. The HP briefs are out on the web. They're also on Eric's USB drive, which is a wealth of information. Okay, so now we can compare the development system with the 92, and the boards don't look quite the same. By the way, you get this prototype feel when you have wire wrap wires connecting up to fix the mistakes on the PC board. So it doesn't look quite the same. However, if you compare the 92 development system to the 97, you'll see the 97 has the PC board coming up the side, and that's connecting up to the card reader so that the data comes into the system on the card reader. And this has data coming up to these are buffers, hex buffers, coming up to connect on the connector side. Again, this is the detail of the connector. Okay, so if you had looked real careful at the picture I showed at the bottom of the unit, it says bad on the PIC chip, which is not a good sign. So even if we do figure out what the connector connects up to, finding a PIC chip that will work with this system is very unlikely. Okay, and that's the first presentation.